Tonight we're going to make the key in Autodesk Inventor. Here's the key, 18 of 24. It's a beautiful, challenging project. It'll be excellent for your portfolio for employment and or whatever opportunities you have out there. So the first thing we want to do is go ahead and open up a new drawing. It's going to be a model in inches, so that's already the default settings. We're going to turn our planes on. We're going to go to our usual isometric view, and then now we're going to stop and talk. The majority of this you can make on your own. This front end is straightforward. This the key portion of it is straightforward. It's just annoying. It's small and lots of little notches. But then life goes to heck in a handbasket back here. Okay? That's where all the difficulty is, trying to figure out how do I make that geometry happen. That's really the big question. When you're looking at all the possible ways to make this thing, what is it that you can do? So we have to analyze the image, and we have to think about what this key is going to look like. Now, if any of you have ever seen like skeleton keys, which is what these are basically. So if you go over here, we'll just look up keys in general. Let's see what they show up. The Florida keys, minute keys. So here's a nice, that one work? I'm trying to find something that, here's a good one. There we go. I knew if I just searched by key, I'd get a little closer to what I was looking for. This looks kind of close without, this is a simplified version of what we're looking for. It's flat. It's got a flat face. This isn't flat. How do we know this isn't flat? We have a diameter reference here. Over here, it kind of looks like it's flat, but it can't be literally flat. There's got to be some type of geometry. Just like here, you see some shape, right? So if I look at this key, it is different here in the neck area, and that's definitely shows that there's some kind of transition. It is saying here that it's got a shade, the shaded area right here. See, this area is a cutaway. It does claim to have a radius here, and this is a diameter, so that's this piece right here. It's this radius is referring to this, the neck connection, which was like this connection here. But this radius here, that's the one that really gets to me, because it shows a radius that far into the part, whereas this one you could clearly see is flat. It's not like this one. So let's back out a little bit and let's look at some other keys. A lot of these have flat backs. They're very simplified. Oh, now I think we're getting somewhere. See the back of that one? See that? That looks like a lot more, minus the house in the front of it. Yeah. Ignore the big house in the front of there. Back here, you see that? That looks more like what I think is happening here. Okay? So that's going to be our visual guide. Does that make sense? Of what we think this is going to look like. The neck area is different over here from here. There's some kind of transition going on. But very distinctly it looks like there's that material here, especially up here, that you have the 375, this dimension here. So that we're going to assume that it looks more like this. All right? That's what we're going to go with. So with that in mind, I'm going to minimize this. We're going to come back here and we're going to think, how are we going to build something that looks like that? Now, symmetry. What do you notice here? You have 375 down here, you have 75 up here. This reminds me a lot of some other drawings that have been done in the past. One of them I don't think you've done in here, but calipers. There's a caliper drawing some of you may have done in the past. Something with symmetry in it, but possibly not in this class. So if I try to take this shape, there's a different color pen, and just focus on this area right here. I see an exterior shape. It looks like this, and then it does this. See that? If I look at it on the side. And I see on the inside something that looks like an 8, but not closed, correct? This is exaggerated, and it's using a mouse on the snipping tool, so it's definitely not well drawn. But you see this 8? It looks like an 8 to me. So that means the top half is the same as the bottom half. Did you hear that? The top half is the same as the bottom half. Now when I look at the home mode, this mode, I want this front piece. This is the front of my part. So that's the front. Which means this is the right side. So this is the side that I'm going to go into to try to make my sketch. And let's figure this out. I can try to just draw the basic geometry and see what it's going to look like. So if I look at this, we have 0.75. We have 0.375 right here, the boxes I made. So if we go ahead and start the sketch, whoops, I exited out of my sketch. I was in it. And we're going to, let's say, construction geometry. So I turn this on so I can get a little bit of clarity of what I'm making. So I'm going to draw a line right there. Then I'm going to offset my line a distance of 0.375. All right? What I just did was identify where the centers of these circles are. See that? So I'm presuming that this is at 0.375. Got it? That's what I'm presuming. So I have a circle that's there. So if I go ahead and draw that circle right here, just the circle I'd like to be a solid object, so I just changed the format on that. Do we have a diameter on that thing? I'm going to have to clear some stuff up because I can't, I've got too much clutter in this picture. What do we have? What do we know? What do we see? We have a inside radius, this thing right here. It gives it to us right there. Okay? So the radius is 0.5. That's diameter, remember that. So that's why I'm saying times 2. That way I'll get the radius of 0.5. Get it? So now we see the circle, and we see where it ends here. If we go ahead and trim, well, it'll trim everything. So what should we draw to avoid getting everything trimmed? We're going to draw a center line straight down through the middle of it, construction line. So that way we can go ahead and focus on this piece right there. Now, some of you might be saying, and I agree with you, you should probably draw the whole 8, not just a piece of it. But for now, if we can make half of this, we can always mirror it to make the other half. Meaning, if we made this, it won't technically be half, but quarter. If we make this piece right here, what I put in the box, which means this shape, which is already there, that's this shape. Now we need to add this other shape. So what I'm going to do is change to a different color. We'll go with fuchsia. So, see this, I'm making it more pronounced. See that shape? This is the shape I'm after next, making this back. That's this crazy shape I just scribbled there. Now this shape is how far away from the first shape? 375, because that's that diameter, right? So if I put that reference in, that's another circle. And what radius is that circle? 0.875. Does it share the same center? Before I assume anything, because we all know what assume stands for. The answer is yes. We never want to assume. We do enough of that as it is, right? So this as well I want to convert to not be a object I need to worry about as a construction. Let's go ahead and trim. I'll trim to there. Why? Because that does not loop in. Do you notice that? This back looks straight. It doesn't loop in. Because you'll notice if it did it the other way, let me maximize, not minimize. Maximize this for a minute. If I undo, you see how that loops in? That would mean the back side would have a curve into it. It doesn't, and if we look at our photographic sample, honestly we can't tell because the backside of this we can't see. And most of the keys, when you look at them, their backsides are not dipping in. If anything, the backside is straight or curved out when I look at all these different keys. So it's not dipping it. Because of that, we go ahead and trim this off because it's not dipping it. So back here, it's going to be a vertical line that just goes straight. And that also will be turned into a normal line type. So that shape defines this geometry of what's going on here. So we have these two shapes. So then you ask yourself, well, what's that going to give us? That gives us the pathway of making this object. That's what this literally is. This is a pathway to completion of this object. So basically we've created the driveway for our shape. Now how to make such a weird looking object that changes geometry, literally. Did you notice that? When you look at how it looks, this thing's gorgeous, but look how it changes. The smoothness, it's transitioning from a circle up here. No, not now. Yeah, boy. It changes from a circle over here to some kind of ovally thing down here. It's not a normal shape. So the tool to do that with is LOFT. That is the key to making the key. No groans from the peanut gallery? Hi. You're not trying not to, oh, you're trying to make a key, so you're ignoring me. Got it. The key to making the key is the LOFT command. Got it? That's your solution. That's how this is going to get made. That you can go from one odd shape to another odd shape. And the shapes don't have to match. They can be distinctly different. That's why I absolutely love the sample they give. See that visual? can't. I have to leave it there. See that visual of how that shape looks? That distinctly shows you how weird the geometry can get. And that's what this is going to do. That's going to help you develop that geometry. What's interesting about loft is you have to actually make the shapes in the plane opposite, like you see here. See this? The circle is in which direction? This direction. So the ideal way to make this, I'm going to open this up again, is to actually do what? My favorite tool. What I like to do a lot. Project geometry. I project geometry all the time. I don't want to project the entire curve. I just want to project the point. See that? I only want to project the point. And that way when I draw my circle, you see I have circle, tangent, tangent. I don't need tangent, but I can do circle somewhere in here and touch the top. See that? I can take the bottom of it, hold my control key down, take the point. If I make a tangent, obviously nothing happens, because what does tangency require? Another actual line. I could achieve that, for those of you that are thinking about it. I agree with you. Yeah, I could draw a horizontal line, and then take my circle and make a tangent to that horizontal line. You're correct. You notice how it shoved it off center? Whee! It's swinging back and forth. So how can I fix that? If I take this, take my center, center of my circle and my axis center, I can coincident them, maybe. Let's find out. Can I? There we go. There it goes. So I made a coincident with the center reference. You could do it that way, or I could draw a line at the top, a line at the bottom, make a tangent to both. See that? There's a couple of different ways to make that happen. This, by the way, if I check the diameter, is or should be, ooh, it's not. So what's supposed to be the diameter of that thing? 375, and it's not quite 375. So let's find out how to make that correctly. If I make a line, a construction line, hello, from endpoint to endpoint, that line is 0.39 long, and that's the true size of that. So I wonder, do you think maybe some assuming may have happened over here, or some geometry might be off? Let's find out. Because the gap we should have in sketch 1, and perhaps that was the mistake made here, I did not actually check the distance from here to here, did I? No. So if I check this distance, I want to make that 375. See that? So that was my mistake. I didn't check for that. What else should I be checking for? Let's see. This isn't fully constrained, so what does it do? Oh, it moves a lot. Notice that? Which means this and this need to be collinear. Okay, that'll help there. Let's see if I did that. Okay, that's collinear now. Now what's going on? Why is it moving back and forth, guys? What else is missing? This doesn't have a house. See that? This isn't locked into anything. The only lock-in it has is all the way over here. It has a specific point of reference from this center. That's the lock. Annoyingly, did we build any of that? No. So there's two locking points. This guy here the 8.25 to the end of the nose. See that? And this point here. So we need those in. Got to put those in the drawing. If they're not in the drawing, obviously you could tell we're having problems, right? Because we can't lock this in correctly. So let's pan over and draw essentially some construction geometry that's going to help us lock this puppy down. So we'll go from there out here, and we're going to dimension this, the end of this line to the center of this. That needs to be 8.25. Okay? And then we need another point somewhere in here. That's going to be from here to this center, dimension, sorry, from here to this center, a very interesting number, 1.6712. Now what's the problem? It still moves, doesn't it? Because this isn't locked in any way, shape, or form. So something has to get locked in. So we're going to lock this point down using the fix command, which looks like a little padlock. And just by doing that, I locked everything else in. Just by padlocking the point. Because you need something in a fixed position. It's kind of like putting something on the table, right? Your table's not moving, so when you put a cup down on it, you're good. Your cup's not going to move. But if your table was at an angle and nothing could fit on the surface, your cup would slide right off if the table wasn't level, right? Yeah, that's kind of what's happening here. Once I lock these things in, I gave it a locked position. This is a locked position. Now it's constrained. It needed 3 constraints, though. One was the 8.25. Well, could I get away without that? Let's find out. I think the answer is yes. Yeah, and now I can get away with that because I have this guy. Locked in space. It's not going anywhere. It's done. Now what do you notice? Did I lock it in a good spot or a bad spot? Guys, what do you think? Where's this curve? Did I mess up? You know I did. Come on, it's okay, be honest. What did I forget? The center is where the arc ends, right? So where's the real lock? Right here. That was the real lock. Because that center, this is all based on the center of this arc. That's the real lock. So when I got out of it earlier, I didn't lock anything down. So that's why I was getting the wrong numbers. Now everything is locked down. I didn't need the lock on that end. It's good to have this information for the next step. About 2 steps later, to be honest. But I really didn't need it for this one. For this one, I needed to make sure that the center of my arc was locked down. I say preferably to the plane, because that's going to make the next step easier. See how I attached it to the plane? So when I finish my sketch and I go back to my second sketch and I edit that sketch, this piece of the puzzle will be easy because this piece, you see, if I take this to this, locks right in. So now I have this diameter, and I'm double checking my dimension. It's 375, and it's 375 there. I'm good to go. I rinse and repeat this action down here. I finish this sketch, My shape down here is where I build my next object. And if I go to isometric, I don't have a diameter, but shall we say that the diameter is consistent? So this 3.75 diameter is the same down here. But you're going to find out what? This is not 3.75. From here, I have to, what do I have to do before I can do this? Remember? Project geometry. I got to project my points. If I don't have my points projected, I can't do anything. If I check this dimension from here to here, that is not 3/8 of an inch. But that's because this dips in. That makes sense. Correct? The diameter, however, is 3/8 of an inch. So I'm going to use my offset tool, pick my, if I have anything. Do I have anything to offset? No. I need to project geometry again and project that line so I can use my offset tool. So I can offset, what's the distance? Not 3/8. 3/8 is the diameter. 0.375 divided by 2. If I have that, then I have my geometry that I need to build my shape. This has to be construction geometry, Gesundheit. And instead of making a circle, I'm going to make an ellipse. To make this a little easier for myself, I want a line. Can I get to the midpoint? No, I'm going to have to draw it. A construction line. Hold on. A construction line that is centered so that when I go to the ellipse command, I can find the center without a lot of work. Bingo. That's how you draw an ellipse. For those of you that have had AutoCAD, remember how you did ellipses in AutoCAD? Maybe? This is how you do an ellipse in Inventor as well. The only thing I need to do is make that tangent. So I have my two shapes. So I have my circle up here and my ellipse down here, and I have my pathway. Now when I go to loft this thing, here's my object A. Here's my, notice, what did it do? When I picked it, what did it pick? Did it only pick the circle? What else did it pick? Say again? The dimensions I expected to pick, but what else did it select? Everything in white it selected. So did it pick a big long line? Okay. If you ever see that happen, you have an issue. You need to get rid of it. Because all you want is the clean shapes of what you're going to work with. Any extra objects, you need to turn them into construction geometry or delete them. If you don't, they will fight you. Okay? So you have to turn it into construction geometry. Now when you go to loft, because that's the first thing I'll do when I come up to you when you're having this problem. Why can't I loft? I'll say, did anything highlight out of the ordinary when you did loft? And I know the answer is going to be no. Until we analyze the image. So again, when you do the loft, I pick my object. The object is highlighted, solid white. Everything else is dashed lines. That's good. I pick my next object. Everything is dashed lines except my ellipse. That's good. Notice what it did. Isn't that beautiful? It did a straight shot. I'm going to go in the side view so you can see what it did. See how that? It just took a straight line from this center to this center. That's all it did. Now I go to rails. Remember what I said? Rails. Okay, rails. Okay, rails is when it's picking this. Did you see that? Watch. Look what it did. I picked that rail. Hold on, let me undo. Or delete. When I pick this rail, it tries to follow that curvature. When I pick this rail, starts following that curvature. You notice that? It's not perfect. You guys see that? If I go to the side view, now you see how beautiful it looks. Okay, again. Sketch A, sketch these two sketches together, sketch 2 to sketch 3. Without any rails, it takes a straight beeline, boom, shot to it. I go into rails, I select this inner curve, it gives it an inside chin. I like to say it like the chin. I just gave it a, what do you call it? Tuck pointing? I don't know. And now the back side, boom. See that? I picked that rail and said, these are your parameters that I want you to stay inside. If I wanted to pick another shape, somewhere in the middle, I pick another shape. Get it? I can do whatever I want. In this case, we just want this one shape. When I hit OK, that's what I get. I get that shape. From this object to this object. It is the command called LOFT. It's used in the plumbing industry a lot. If you ever look at those gorgeous faucets at the store. On the CAD side of a house, that's how we make them. If you look at some fancy mice, anyone look at a pump dispenser on a hand sanitizer, this gorgeous shape? Yeah, that's how we make them. Cool? Any of these odd looking shapes. Now once you have the first one, this is where my laziness takes over. I like to mirror. Okay, I'm going to mirror this entire thing along this edge. See? And I hit OK. That's the bottom of my key. I'm going to do it one more time. And I'm going to mirror this whole entity, both sets, along this body and hit OK. Okay? So then what you have is that back piece, the pain in the Badinsky piece. The next job is connecting this to the rest of the body. And that's this neck area right here. That's the next piece. So now we're working on this piece. This piece is done. This geometry here is done. Okay, this piece is completed. Now we're moving on to making this piece. Okay, right here, this piece. I changed to green just to try to be different. Okay, and when we do half of this, we're going to mirror it to get the bottom half. Or maybe we'll do the whole thing, we'll see. Now, how do you think we'll do this? So we've got this shape here, we've got this shape here. What do you think we should use, guys? Now that I've introduced you to a brand new command, we're going to use the LOFT again. We're just going to use it in a different direction for a different kind of shape. So when we go in here and we sketch, now remember I told you that we don't need that one little element up there, this guy, this piece, remember that? Now we need it. That's what I said, like 2 steps later, we're going to need that. This is the 2 steps later. We need this in order to be able to, when I do project geometry, can I do it? Yeah, it won't let me get into that sketch. Yeah. I won't be able to project that geometry, but I can do cut edges. I did cut edges so I can get this edge. See that? Now, why would I use that command? Project cut edges. Have we used that before? Anything that is round that I need to get the outline of, anytime it's spherical, round shape, whatever, project cut edges is what I use. Okay? That at least gives me that geometry to work with. Now the question is, I got to get to the other side, right? So from the center, if I draw a line, a construction line, from my center out, okay, and then dimension this thing, That's that 1.6712. I drew it back in. There you go. See that? At this point, I have what? My other reference geometry. I'll draw it down here just to draw it. What is that going to represent? My what? If I drew this out, half of this diameter right here. So it's 1.125 divided by 2. So that 1.125 divided by 2. Now this is where I would throw an arc from here to somewhere on this body. I'd have an arc that looks like that. This will be a solid object. What do you think this arc should be to this arc? Tangent. You're absolutely correct. You got it. It's tangent. This arc to this arc, they need to be tangent. When we drop in the radius of 0.5, then it locks in. This I can mirror to the other side. Let's mirror this object along this plane. Let's see if it works, and apply. That's that radius 0.5 net. See that? When we go home, where this and this meet is a perfect vertical position, vertical line reference, FYI. That is where I need to create a shape. So when I put in my plane, I have to put my plane in relationship to that position. So I put in a work plane that's going to be referenced from there to this point. See that? Okay, let me do that again. Let me open this up and I'll show you. It'll be much easier if you see it here. Go to plane. I pick this plane and I pick that point. And you see how it pulls a plane right to that face. I can hit plane again and go from here to this point. Uh-oh. Let me try that again. Plane. Pick this object to this point. There it goes. So I have this plane and this plane to work with. Just like the original loft, I had a circle up here and an ellipse down here, right? They were on opposite planes. This time they're on the same plane. They're one plane to another plane. They're in alignment with each other. They're not perpendicular to each other. And then on this side I would have to draw, what's the shape, guys? What does it look like? Oh, that's a round. It's it's a circle. What's the diameter of that thing? First I have to do what, guys? What do I have to pull out? Project what? The points. Remember? Gotta project the points. It's always good to project the points. And then I could draw a circle. I'm being intensely lazy because all I do is put all the points in. So this should be perfect. If I put in my diameter in here for reference, that's it. See? It's 1.125. So that's done. How about back here? So that one's done. Back here is going to be the next one. Create a sketch here. This one gets a little interesting because it has the same problem as the other thing. It's not really round. So this is another example of where project cut edges is absolutely necessary. Wherever my plane cuts into the object, that's where it creates the geometry. You don't have to figure it out, in other words. Did you see that? Did you see that? Were you sitting there trying to figure out how the heck am I going to follow that weird curve, right? Right here, like, man, how am I going to follow this outline? You don't have to. Project cut edges is your friend. Fun. Isn't that beautiful? Now it's the same thing. You finish the sketch. You go to loft. You use loft because the shapes are different. You use loft because the shapes are different. Anytime you want to combine two pieces of geometry where the shapes are not the same, and you want to merge them in a beautiful, tangential, smooth surfaces way, you use LOFT. Get it? You don't extrude one object and then extrude the other object, and wherever they crash into each other, done. No, you want them to combine in a beautiful way, so you have the two shapes, and then you have the curves that they need to follow. So that's what we're going to... Well, we'll find out. So the objects in question is this object and this object. See that? It flutes automatically. See that? The flute, so it connects automatically. Now you have to click on rails. You have to actually click into the rail section. It won't do it for you. It will not do it for you. It will not do it for you. It will not do it for you. You have to click over by rail. I forgot. What do I have to do? Yeah, I got to click over to rails. All right. Then I can pick this. Ooh, ouch. What do you think's going to happen, guys? No, because of what? Everything. Remember how I said, if you see too much highlight, solid white, you know you're in trouble. So we got to stop ourselves. Okay, that's our problem. So we got to go into this thing and edit that sketch. Oof. Yeah, that sketch has way too much geometry that it's trying to lock onto. All of that geometry you got to turn into construction lines. Got it? Did you see that? All of that had to be turned into... Make sure everything is construction. Everything. Got it? It's better to have too much construction than make something a non-construction line than have too many things solid lines. Okay? Now, hopefully it'll work. Let's find out. Let's give it a whirl. Loft. First, I'm in the selections category where I'm picking... This is best done in isometric. Sorry. Right there. Pick this object. And I pick this object. That's how I get the flute look. Boom. Connects the two. Then I have to click in rails. Please remember that. I've had students click, 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 and that's... Well, did you click to rails? Huh? Remember that. Click to rails. And now, let's see if I can do this. Select sketch. Okay, you see how only that highlighted? Okay, tucked in. Almost home. Tucked in. Let's go to isometric. Looks good. Go to top view. I don't like that. So what did I forget? Gosh darn it, you workers. You think I should have some rails on this side too? Yeah. See, I put rails up here and the bottom here, but I gotta go into this view and add rails too. And in this view, no, yeah, I did project cut edges. This I'm going to turn into what? Construction. Remember that? Yes, you're right. What
if you do turn everything into construction, all that other stuff, but you can still only get one of the rails to work properly?
We'll have to look at it. Could be open. There's a couple of reasons it won't work.
Right.
Let me go back home to this one. All right. So right now, what we're trying to do is capture a reference line, because right now we're on this plane, and I want to project geometry. There we go. And I want to turn this into construction line so I can have something to lock onto. So I'm going to go into this top view, go into my arc, and let's see what we can do. We're going to connect to the arc, connect there. Now, it looked like it snapped into a specific spot. I don't want it to snap into anything, so I'm going to go out here instead. So I have a little bit of freedom. Drag this arc over. I actually want to make sure this arc tangencies to the side wall. Notice how it looks like it went into it? Did you notice that? So I do see some oddities there. We're going to trim that back. Let's try the radius of 1/2 inch, right? Is that what? Ooh, that's too far in. So on the side, obviously it's not 1/2 inch. Maybe if we just smoothened it out. What do you think? What do you notice when we're smoothing it out? Do you notice how it's ending in a different place? See that? This is, I'm going to make it flush. So it gets a nice curve in and stops flush with the other body. Because I don't think the radius on this can be 1/2 inch because it cuts in too deep. So the sides, I think, are random, for lack of a better word. You want this to be tangent here and then meeting at that intersection. If I mirror this, and we'll know if it looks good, because that'll be the true test of anything, as always. So the mirror line, oh, I don't have a mirror line. Hello. I need a mirror line. Is that one in this? Yeah, it is. It's right there. Okay. Okay, let me do that one more time. Mirror, object. It's not picking that mirror line. Okay, let's try that one more time. So for some reason it's not selecting that object. So I'm going to change this to a construction. I shouldn't have to add a second object, but it looks like I have to. Click this, the mirror line will be this, and hit apply. And done. So that would be the side guides. Now what do you notice? Where are the side guides versus these guides? Are they in the same place? Do you see some logic issues? I do. Yeah. So the sides might be something that have to be handled separately, depending on... I don't think we can get them all at the same time. We could try. Let's see what happens. I'm always open for a little opportunity and see what we can get done here, but I don't know if this is going to work. So here's object 1, here's object 2. On the rail side, we're going to pick curvature 1, curvature 2, and you see how we're already, do you see anything? Do you see how nothing showed? What does that tell you? It's going to fail. Guaranteed, by the way. It's going to fail, which means we have to accept a certain reality. It's going to be a two-step process to get this thing to actually merge. Here's the steps. Here are the steps. At this sketch phase, what do you know is its termination point? This crossing line. It cannot go past. Your rails cannot extend past your start and stop points. The alpha and the omega. Does this make sense? The alpha piece is here, and then the omega piece, the end piece, is there. I can't have my guide rails go past them, which means I have to cut these off. Literally. Yeah. Well, we got to figure that out, because that's the question. How do I... Whoops, that turned out badly. First thing I want to do is project geometry so I have my reference there. And I literally have to trim these back, because I got to cut them off. That's as far as they can go. Now, I have another opportunity. We'll see what happens. I'll wait. I'll show you. See, they're here, okay? But you see your object is back there, right? Okay, now watch what's going to happen. Loft, beginning, alpha, omega, and rails. Come on, rails. There we go. Tuck in. See that? Tuck in. Do you see anything happen? Now what's wrong? What's the next issue? It's not closed. You're absolutely right. That's the problem. Okay? See this? I have a big gap. Drawing a line across isn't going to solve the gap, by the way. Your inner shape has to fit within those parameters. So if I try to create a... and go ahead. No, okay. Try to create a, what do you think, an ellipse, maybe? Created a sketch of an elliptical shape that would fit within the parameters that I have to work with. See how complicated it's getting? This matchup is tight. It's not a perfect fit. So how can we improve on this? Why is it an issue? Where should we try to extend to? Might be the better question. Right now I have it on the edge of the key. Where should I be putting my plane? Where would be a better place? When you see this sketch right here, see where it is? It's on the edge, right? It's near the edge. You noticed how this naturally wanted to go to the midpoint, right? When we did these? Remember this rail? This rail would naturally extend to where? To this position, right? Would it naturally extend to this spot out here somewhere? Like this one did? See how that one naturally extended to that position? See how it's, oh, now I messed it up. If I delete this side, isn't it? And drew in an arc. See that? And made that tangent. Not quite. Yep, that didn't work. This arc. Let me at least make it equal. This and this. It naturally went to which position? The middle of the ellipse, the center of that curve, right? So if it naturally goes there, this I can make go to there too. This shape is in the wrong spot. That's my problem. That shape is in the wrong spot. If I delete that shape and the related plane, oh, I should probably not destroy everything in the process of doing this. You will get that. You notice how everything else, like now you've got something pink and you got to fix that. Those are the things that you have to repair. Your new plane, of all things, would go from here to that point. That's through the middle of the part. That's where you want to be creating that sketch of your project edges through that center. You don't want to be anywhere other than the dead center of that ellipse on that side. Because then Yeah, this sketch is in a good spot. That's in a good spot. That sketch is in a bad spot. Which one is that? Hold on. There's so many sketches. This guy, can I move it? No. This sketch is in a bad spot. See how I deleted one object and all of a sudden I've got a bunch of work on the other objects. Why? Because of parent-child relationships. Remember that. Those gosh darn parent-child relationships are fighting me. So you have to be mindful of these issues. Don't stress out over them, just appreciate that they're there. By doing what I did, I kind of messed up my object. What's the diameter again, guys? 1.125? So now I have to repair my objects a little bit. You're going to get a bunch of little errors. This is wrong, that's wrong. Get rid of this, get rid of that. So there are things that I'm going to have to account for. That I don't want to have to deal with. So this guy should be locked now. Yep, finish that sketch. Still get another error, not sure where. Okay, that one is still saying it's in there. When you see this, if I go and update, I don't have update as an option right now. But this particular one is not happy with me, this object. It's not telling me nice. Where it's wrong? Let's locate the update. Yeah, local update. It's not telling me where it's upset, but it's telling me that there's something going on there. You'll have that, which is very annoying. I have to apologize to you about that. Not that I can fix it, but I promise you will have that problem. We all end up with one of those. So there's that one. That one's fixed. Let's see. This last one is fixed. So now I need to put my last two rails in. That's going this way again. I need endpoints. Protect that geometry. This I turn into construction, so it doesn't fight me. What do I have to do over here, guys? Project geometry. I gotta project this, right? Project that edge. See that? This whole thing, I turn into what? Construction. Otherwise, it's gonna fight me. Now when I put my arc in, you're gonna find out that you have a little bit of a snafu, because yeah, it's not a clean, it requires a little extra work. This radius of 0.5, which isn't the problem. You can make this tangent to this, which isn't the problem either, but you'll notice you have this piece right here that you do have a problem with. So you're unable to get that. You have to actually complete the arc. So you go from here, and of all things, you're going to create an arc going the other way. That's going to be tangent to this body. So when you see it in this view, did it disappear on? Yes, it did. Let's try that one more time. This object right here, this and this tangent. It disappears. So let's try that one more time. All right, let's do this. You and you. See these two objects? Let's make them collinear. No, it's not going to happen either. Nope. Come on, you. It's attached to that other arc. It won't. It's attached to this endpoint, I think, is the reason it won't work for me. What's that outer radius again? Off the drawing, guys? Is that 0.88? I'm going to draw it. 0.875 was the radius, right? Yeah. See how I had to act? I just drew it because it was less painful. I am going to project this geometry of my plane, so I have it as a reference. Turn that into construction. Then I can just trim back. So that's how I get around that problem. The rest of the object right there, get rid of that. So now you have that shape. See that? And you can tell that there's a small gap. Tiny gap. There we go. That is now tangent. And shares a tiny gap. Do you see that? Now watch the computer crash. No, I was expecting it to crash any second there. Let me drag you over. Just, no. See, you two do not want to. There's a small, see that tiniest of gaps. Wow. I don't know if that's connected. Okay, let's cross our fingers and hope it's connected. We're going to do the same thing. All of this should be construction, which it is. We're going to mirror this. Let's make sure we have a mirror line. Okay, make sure that mirror line is construction geometry. Then we're going to mirror this. That shape along this edge. Okay. Cross our fingers. We're going to hit save this time because I don't trust. I don't want to lose all the work, right? Has it happened yet? It has to me in the middle of presenting. Now we're going to do loft. We've got this object and this object. Okay, there we have that neck. Now we're going to go to the rails. This rail. Ooh, tucked in beautifully. This rail. What do you think? It's going to fail. Yes. The minute we lost sight of that image, it's going to fail. Okay. Now we're going to try it the other way. Loft this object to this object. Okay, we see again the beautiful shape. Then we're going to go to rails. We're going to pick this rail. Wow. Okay, so that's where the problem is. It's right there. It's in this geometry right there. That connection, remember how we were in there trying to get it to fix? Obviously it's not fixed. Looks good, it's a dud. Okay, so this is where the mistake is. It's right there. Somewhere here. Yeah, and you can see it. All I did was drag it a little bit and it immediately went away. So we know this is not connecting. This is not. Let's try one thing. Let me try. This object to this object. Let's make them tangent. Okay, they exist already, which means there really is a gap. So if I throw, draw a line? Is that what you just said? Yeah, I like your answer. I think I'm going to go with it. I don't know if it's going to work, but we're going to try it. Okay, it did close, I mean, maybe it's closed now, we'll see. Okay, let's go back in there, we're going to edit that sketch again. Got to mirror it. Hit done. Oops, I must have missed something. There we go. Apply, and done. Finish. Hit save again. Go into this view. All right, let's give it a whirl. Loft, object A, object B. 1 second. Rails. Nope, that'll go. I picked it and it wouldn't pick that part. See that? No go. Even if I pick them all, doesn't matter. So now we get it to work beautifully in one direction but not the other. So adding that line was not the solution. It requires a little extra finesse. So my 10.5 cents to you is if you can get it to meet properly at this position out here, then you could do that. In the outsides, you're going to end up with that little dip. Now, here's the funny part. When you look at the image that we work off of, where's that drawing? There it is. What do you notice? Don't you notice an odd connection there anyways? So there's something going on there. We just don't know exactly how it looks there. You were going to add.
Couldn't you put a circle in to connect those two if you were to do it from the top half of that where that second circle is and then just trim it to that line?
Mm-hmm. Been there.
Connect automatically?
It's not. That's the problem. Because we have that in there. For some reason, when we draw this in relationship to this, it is off by a hair. And I mean, like, come on, you. Watch it crash.
It's going to happen. It does it all the time for me on SolidWorks.
Thankfully, it did not. It's not SolidWorks. That's my answer to you. All right, so here we go. I got it in there, but I don't know if it's really in a good spot. We'll try. I'm always keen, because we drew it the first time. Now, because we drew the first circle, but it was off by a hair, literally. See, when it wants to trim, you see how it wants to go all the way. So the idea is to lock it to that point. But I don't know if that's about as good as it's going to get. So hopefully, but if there's a small inkling of an overlap, it won't work. Did you notice that? Or a gap or anything. That's the key when you make the rail has to be perfect. So now let's go to mirror. Let's try this one more time. Yeah, we have an object that we're going to have to turn into construction geometry in a minute. Yeah, let's try it again. See that inner arc? See what highlighted? Yeah. Let's try this one more time. This inner arc right here has to be construction. There we go. Now let's try this one more time. Mirror. Mirror line. Apply. Which means you redraw it. And y'all know how much I love to redraw things. Let's try it. Tangent. Throw in the radius. Trimming, it's not the issue. You got to draw another circle in, just like we did above. Draw another point in. Look how much extra steps. See all those steps that you have to go through to get the alignment just right? Okay. Now that did not turn That's what makes me a little nervous. It did not. Come on. There we go. You want it to be fully constrained, so it's locked in. So there we go. Now maybe it'll work. Let's save again. I'm going to loft again. This object to this object. Rails. Okay, see how it picked the whole thing? I know. See how it picked the whole thing? And it stayed. I promise not to go into singing. Don't worry, guys. I promise. Now, the real test. Ooh, did you see? Did it disappear? And then, oh! Oh, almost. So, but that's good. Did you see how everything works except one? So what does that mean? Which one has to get fixed? This one. Just that one. We're that much closer. By the way, this is the torture you should anticipate for yourself when you are doing this project. But you see what it takes. Patience, a little bit of humor, maybe a lot of humor. A lot of humor, all right? Oh, take a deep breath. That's it. Well, wait a minute. A whole lot of patience, okay? But definitely a lot of humor. So we got that down pat. And then if I hit OK, I'll get everything. It actually looks really good. I'll get everything but that side. You'll see the slight, you see there's that slight look that it ends up with because of the finagling that had to get done up there. There is a slight something going on up there. We don't know what it is. But this side is the only one that has to get fixed. But I have to be honest. This doesn't look that bad if it was like this. That doesn't look that bad. In fact, that almost kind of looks like that ripple thing that you see in the actual image.
So you mean to say that all that...
No. This side, if I was going to be manufacturing, no, seriously though, if I was manufacturing this product, I'd want it like this side. I will say that to you right now, 100%. Because when I go to how I want this viewed, and I think about what kind of shape, the shaded, how realistic I want it to look, and I turn all of my planes off, and now we're going to say, well, which face looks nicer? We're going to have that conversation. See this? When I look at this side, and I orbit this a bit to show you what that looks like, that's a pretty nice, clean face. If I move to this side, it's not that bad, to be honest. But look how sharp that line is. From a perspective, you see that line right there?
Looks like it was made for a right-handed person.
Something. Right, it definitely looks odd. This one at least has some conformity to it, and it follows the contour of the shape. Yes, will this piece in the manufacturing process require a secondary operation of being buffed or polished? Oh, 100%. Which is how we do faucets, okay? I have cutouts of faucets in a box over there. And when you look at how castings are, they're not perfect, but yet the faucet you see in your house, it's very pretty and very tangential. It's close coming out of the cast. But it usually has some secondary operations to smoothen it out and get the bumps out of it. The key is to minimize the bumps. So here you have less of that. It's a smoother transition. Whereas on this side, so if I had to choose which kind of keyway I'd prefer, I'd still prefer this side, where it dips in and it's a little more conforming to my hand than this side, which kind of bumps out, because that's what this guy does, bumps out. All right? So the effort is worth it, is what I'm saying, to do it, to get it to fix itself. So the only one that has to get fixed is this side. And I don't exactly know what its malfunction is.
The other line looks a little long.
Well, it's always the question, which, it could be a very, I usually say the two have to connect horizontally to each other. So if they don't connect, see this one, the question is, where does this one end? That ends there. So this line has to end there too. If it doesn't, if the two arcs don't end at the same spot, we already know that that's where the biggest problem is, right? Because that's what happened earlier. So then if I just match their radiuses, that could be it, of all things. Could just literally be that. And I'll just turn that into construction geometry so it stays out of my way. Now I updated it. Now the question would be, if I update my loft, go over here and add this. There it goes. See that? That's all it was. Remember how I said your lines cannot extend past the shape that you're lofting to and from? It was probably just a little bit past it. Now when you hit OK, voila, you get the complete shape. So now when we look at the top view, that's what we get. When you look at the right side view, that's what you get. And then all the angles. And it does look prettier. Aesthetics matter, especially when you're selling a product. You want that curve in there. Cool? Got it? That's how you'd make the keyway, the toughest part of it. Thank you. Have a good night. Well.